Welcome to my channel. Look here, it is given an important integration, a definite integration problem, which is usually asked in board exams and competitive exams. So we are going to elaborate this, we are going to solve this, and how can we use the formulas of definite integration to solve this problem, we will look in this video. So there are two formulas which is used in this problem. So this is the formula. The first definite integration formula is 0 to a fx dx equals to 0 to a f of a minus x dx, and 0 to 2a fx dx equals to 2 times 0 to a fx dx if f of 2a minus x equals to fx, and if f of 2a minus x equals to minus of fx, then this integration will be 0. So first of all, we explain second formula, and how can explain second formula, and then we use this formula to solve the given this definite integration. So we are going to we have to solve this definite integration, but we are going to explain the second formula in this video, and then we go to solve the that given definite integration formula, 0 to pi by 2 log sin x dx. So again, let's explain about the second formula. First, we are going to explain about the second formula, that how can we use this. So we have given a formula that first explain. We have given a definite integration problem, that is 0 to pi sin x dx, and we know that here fx equals to sin x, and f of pi minus x equals to sin pi minus x equals to sin x, that is fx. So f of pi minus x equals to fx. So by using this second formula, we can write it as 0 to pi by 2. We will half the upper limit, and 2 times this integration becomes 2 times of 0 to pi by 2 sin x dx. Again, we are going to explain this formula by second example, and this becomes 2 minus cos x 0 to pi by 2, and this becomes 2 into minus cos pi by 2 minus plus cos 0, and this becomes 2 into 1 equals to 2. So again, we are going to explain this formula with second example, 0 to pi cos x dx. What will be the value of this integration? We take it as fx equals to cos x. Here f pi minus x equals to cos pi minus x equals to minus of cos x. Since in second quadrant cos theta is negative, so therefore this will be minus cos x, and this is equals to minus fx. So f of pi minus x equals to minus of fx. So therefore f of 2 into pi by 2 minus x equals to minus of fx. So this integration 0 to pi cos x dx becomes 0 by above second formula. Again, we are going to use this formula in solving the given problem, 0 to pi by 2 log sin x dx. This is an important problem, and we are going to use those two formulas in solving this problem. So look at here. We have given problem 0 to pi by 2 log sin x dx. Suppose I equals to 0 to pi by 2 log sin x dx. Take it as first equation. Again, I equals to, this integral would be equal to log sin pi by 2 minus x dx. Since 0 to a, f of x dx equals to 0 to a, f of a minus x dx is equal. This is the property of definite integration. So we have used this in this step. Again, in another step, 0 to pi by 2 log sin pi by 2 minus x equals to cos x. This is the formula. Cos 90 sin 90 minus x equals to cos x, and cos 90 minus x equals to sin x, and take it as second equation. What we do is we add equation 1 and 2. Add 1 and 2. I plus I, LHS left hand side becomes I plus I, and in right hand side this becomes log sin x dx plus log 0 to pi by 2 log cos x dx. This left hand side becomes 2i 0 to pi by 2, and integration becomes this, the sum of two integration becomes a single integration, log sin x plus log cos x dx. Again, we use the property of logarithm. What is the property of logarithm? The property of logarithm is log a plus log b equals to log a into b, log of a into b. This is the property. So log sin x plus log cos x would be log sin x plus log cos x would be log sin x into cos x. Again, we are going to manipulate this in some simple manners. What is the simple manners? The simple manner is, we are first of all we multiply log 2 sin x into cos x, and this becomes 2. We have multiplied with 2 and divided with 2, so there is no change in the expression. Again, this becomes log sin 2x upon 2. We know that 2 sin theta into cos theta equals to sin 2 theta, so we have used this. Again, what we do, we use logarithm. Again, we use the formula of logarithm. And what is the formula? The formula is log a upon b equals to log a minus log b. So this integrand will be, so the integrand will be log sin x. So log sin x plus log cos x would be equal to log sin 2x minus log 2. Thus our integration 2i equals to 0 to pi by 2 log sin x plus log cos x equals dx equals to 0 to pi by 2. This becomes 0 to pi by 2 log sin 2x minus log 2 dx, and this is equal to 2i equals to 0 to pi by 2 log sine 2x dx minus 0 to pi by 2 log 2 dx. Again, we have again 2i equals to 0 to pi by 2 log sine 2x dx minus log 2 0 to pi by 2 dx. Since log 2 is the constant, so we keep it outside the integration. Again, this becomes 0 to pi by 2 log sine 2x dx minus log 2, and integration of 1 is x, so 0 to pi by 2. Again, 0 to pi by 2 log sine 2x dx minus log 2, and what would be this? Pi by 2 minus 0. So this 2i equals to 0 to pi by 2 log sine 2x dx minus pi by 2 log 2. Again, we have, what is the problem now? We have the problem that we have to find out this integration. So we find out this integration by method of substitution, and again take this integral as I1. 2i equals to I1 minus pi by 2 log 2, and take it as a star. This equation take as a star, and now I1, what is I1? I1 is I1 equals to 0 to pi by 2 log sine 2x dx. 0 to pi by 2 log sine 2x dx. We substitute t, in the place of 2x, so dt becomes 2 dx, and dx equals to dt upon 2 by differentiation. Again, at x equals to 0, t lower limit would be 2 into 0 equals to 0, and at x equals to pi by 2, t equals to 2 into pi by 2, and this will be pi. So the integration will be changed to I equals to 0 to pi log sine t dt upon 2, and this can be written as 1 upon 2, since 1 upon 2 is then constant, 0 to pi log sine t dt. Again, we use the formula that we have mentioned earlier. The second formula is, we use f of pi minus t, f of pi minus t equals to log sine of pi minus t equals to, since sine 180 minus theta equals to sine theta, since sine is positive in the second quadrant, so sine pi minus theta equals to sine theta, so this becomes sine t, and this is ft, and this f pi minus t can be written as 2 upon pi by 2 minus t. So this is in the form of 2 pi minus t into 2 pi by 2 minus t into ft. So what is the integration changes to? I1 becomes, by the second formula that we have mentioned earlier, this becomes 1 upon 2 into 2 into 0 to pi by 2 log sine t dt, and this changes to 0 to pi by 2 log sine t dt. Again, the definite integration does not change, does not depend on the variable of integration. So 0 to pi by 2 log sin t dt can be written as 0 to pi by 2 log sin x dx. So this integration would be the same, since the in the place of t and x there is no change in the integration. So again we are going to, and this is what, this is I, and this is I, this is second star. By star and double star we have, what is the double star? The double star is first star equation was 2i equals to I1 minus pi by 2 log 2. So this I1 becomes I, and 2i equals to I minus pi by 2 log 2. Again so 2i equals to I minus pi by 2 log 2, and this 2i minus I equals to minus pi by 2 log 2. This I equals to minus pi by 2 log 2. Therefore this equation, this integration, I, what is I equals to 0 to pi by 2 log sin x dx, and this equals to minus pi by 2 log 2. Thus we have solved the integration. This is an important integration, and we have used the property of definite integration to solve this problem. So this is an important integration, so keep it revising frequently, and this problem is very important for the exams. So thank you, and we are going to end this session. Again we will meet with new lectures.